Hello, everyone. This is Dr. Thiessen, and this is a brief introduction to statistics with a particular focus on the ANOVA test. So, statistical analysis is a methodology that allows us to make sense of data. Some people consider it a branch of mathematics that um, analyzes, interprets numerical data, or that allows you to model and represent data from experiments. But essentially, statistics is used to make decisions. In medicine, it's used to measure disease risk or to analyze the results of a drug trial, politics prediction of election results, and in marketing to track users and customers. In the field of data science, machine learning, and artificial intelligence, the same principles of statistics are used, except that now the data sets are enormous. But the principles are the same. So there are two main types of statistics. There's descriptive statistics, and then there's inferential statistics. Descriptive statistics just describes the data set, represents it graphically or summarizes it, whereas inferential statistics is what is used to determine whether the hypothesis is, should be accepted or not, or to model the data set so that we can make predictions, or we can make estimations about a particular variable and its relationship with another in the data set, in the sample data set. So we have these two types, but the type of inferential or descriptive statistics that we use is depending on the type of the variables that we're looking at. So the variables can come in two main forms, either categorical or numerical. The categorical variables are either nominal or ordinal. The nominal variables are just ones that you can describe by name, that's hence the term nominal. And so the type of fruit, the type of car, the type of tree, the type of animal, those are all nominal variables. The ordinal variables, you also use naming categories, but there is an order to the naming. So first, second, third, freshman, junior, sophomore, senior, there's a certain rank order as far as the military is concerned. So those are all would be ordinal variables. Now, ordinal variables are unique in that they can also sometimes be used as numerical variables, right? And they're used that way a lot in social sciences, especially with the Likert scale tests results, where they have you like something, you don't like it, but you like it somewhat, a lot, or there's variations to it. So that would be considered an ordinal variable. The discrete variables are the ones where you use whole numbers only, right? So the number of children that you have, the number of cars that you own, anything that can only be described using whole numbers, those would be considered discrete variables. Now, if those values can take a range of forms that include fractions or decimals, then that it would be a continuous variable. So, the height and weight and temperature and those kinds of variables would be considered continuous variables. So those are the different types of variables that you have. So here's how we would then describe those variables to represent them, to summarize them, if we're presenting this information. So these two would be representations of categorical variables. So we have either a bar chart or a pie chart are ways that you can represent categorical variables graphically. If it's a continuous variable, we use a histogram to represent the data in that variable. Or we can represent with the mean and the median and the mode and standard deviation. So this applies to continuous variables only. And so the way you would conduct those descriptive type tests in the SPSS would be, you would open up your data set in SPSS, and then you click on the Analyze tab. The Analyze tab is right at the top in the middle, and it's going to be the one that you become most familiar with. It's the most commonly used in data, using SPSS for data analysis, because that's where all the tests are. So you click on Analyze, you click on Descriptive Statistics, and then you go to Frequencies. Now, frequencies is what you would use to get descriptive statistics for categorical variable. If it's a continuous variable, then you would actually go to the descriptives, right? So for a categorical variable, we click on the frequencies. This tab opens up and we move our variable into the variable box here. Then we would click on chart and choose the type of chart that we want, and we get this printed out as a result. If it were a continuous variable, we would click on descriptive statistics, and then we would click on descriptives. And when it opens up, we move our variable over. We would then click on statistics and choose the mean, median, mode, standard deviation, all that kind of stuff. And that would then generate a table somewhat like this. So once we're done with our descriptive statistics, now we can move on to our inferential statistics, right? So remember that we have descriptives and we have inferentials, and this is where we do our essentially hypotheses testing, right? And these are the 4 steps involved in hypotheses testing. You would state your hypothesis based on your research question, your null hypothesis, nothing's happening, no change, no effect. And then you would also state your alternative hypothesis, which is there is something happening, there is a difference, there is a change, there is something statistically significant occurring as far as the results are concerned. Then once you've done that, you're going to set your decision criteria. Fortunately, that's kind of already standardized in the field of statistics, where we use the p-value of less than 0.05. And what that means is that the probability of your results, if the probability is less than 5% or p is less than 0.05, then we would say that these results are statistically significant, right? Because the probability of them happening by chance is less than 0.05. So it is statistically significant. If the p-value is more than 0.05, then we would say that the probability of these results are more than 5% happening by chance, and so we would conclude no statistical significance. So that's a criteria. Alpha is equal to 0.05. Then we would go ahead and compute our statistical test, whatever that test is, t-test, ANOVA, regression, and once we get that, we would then make a decision about our null hypothesis, whether we reject or we accept. So this is a very simplified version of choosing statistical tests, right, based on the type of variables that we have and the research objective. So in this case, if we have numerical values and we want to determine if there's an association between the 2 variables, we would use a regression analysis, right? Or we could use a Pearson correlation. But if we want to actually measure or get some measure of the statistically significant difference between the values for 2 or more groups, then we would use the ANOVA. If it's just 2 groups, we would use the t-test. So, and this is the test where we're going to be focusing on. So the ANOVA stands for Analysis of Variance, and it is used for 2 or more groups. And what it does is it determines whether the difference in the means between these 3 groups or more is actually statistically significant or not. And so we're going to just be doing a one-way ANOVA today. And the hypothesis, the null hypothesis, states that the means are all equal. The alternative hypothesis states that they are not equal. There is a difference between the means of the group. So if we set up our hypothesis testing, so here we have our two hypotheses, and then we have our selection criterion, and then we will run our ANOVA and make a decision. So before we run our ANOVA, I want to give you some idea of what's happening in the background as far as what the computer is calculating to determine the F statistic for the ANOVA test. So what it does is it calculates the sum of squares within the group. So you have the mean of group 1 minus each of the values for each value, and you get the difference and you square that. Once you get that for all the participants in that one group, you would add that together. And then you would do that for each of the groups, and then you would sum it. So you're doing it, summing it for one group, and then each group, and then you're adding all the groups together. And so that would give you the sum of squares within group. Then you would do the same, but except now you're treating all the groups as if they were one. So you put everybody together in one group. You find the mean, then you subtract each value, and you square that, and then you add. So that would give you the sum of squares between the groups, right? And this is the total. But what's really used for the calculating the F statistics is these two values. So first we need the mean square for each of those, and that is calculated by dividing the sum of square by the degree of freedom. And the degree of freedom is a way of representing the error that is contributed for each component that the group is made up of, right? So in this case, we have K, and K would be the number of a participant in each of the group. And then we would do the same thing for between the groups. So now we would have N, which is the total number of participants, minus K, which is the number in the group. So we're assuming that all the groups have the same number. So if we have three groups of 10, this will be 10 minus 1, which is 9. And then we would have 30 minus 3, which would give 27, right? So that we use those values to calculate the mean squares for within and between. And once we have these two, we can then now calculate our F statistics. And based on this value as determined by the two degree of freedom, we can estimate the probability of this F statistic. And if it's more than 0.05, we would have to accept our null hypothesis. If it's less than 0.05, then and only then can we reject our null hypothesis. So in SPSS, this is what it would look like. We would open up our data set, and we go to Analyze, Compare Means, because ANOVA is a comparison of means test. Compare means, one-way ANOVA. That we click on that, it opens up this this interface, and now we can move our variables into the different variable box. And so in the dependent list, we always put the continuous variable, right? So it's either going to be a true continuous variable, or it could be an ordinal variable that's being measured or considered. So we put the value in here, the continuous variable, and then in here we would put the categorical variable. So we're looking at the difference in the groups. This is where we would put our list of the groups that we're looking at, right? And we would also then click, you can't see it because it's hidden here, but behind there's some tabs, some buttons that we can click on. The one we click on is options, and we would choose descriptives because we want to get some descriptives, some basic descriptives about the variables that we're looking at. We click continue, we click OK, and we get this results. So here we have the descriptives, and here we have the ANOVA test results. And so this is looking at the pre-test score for different school settings, right? urban, suburban, rural. And we have the number of participants that make up this group. And here we have the mean for the urban is 49.88. For the suburban is 63.84. For the rural is 51.49. And so there are differences. But what we want to determine is whether that difference is statistically significant or not. And if we look at the results of our ANOVA test, we will see that essentially, so these are the sum of squares that I showed you how they were calculating those values here. And so this is the results there. And so for this particular variable, comparing the mean of the scores, the F statistic is 299.636, and that has a probability of 0.000. So in other words, the probability of getting this F statistics value is less than 0.05. And so because it is less than, we must reject our null hypothesis in favor of the alternative hypothesis. It states that the differences in the mean score is actually statistically significant. Now, there are additional tests that you can do with the ANOVA, the post hoc test, testing the assumptions, and that's going to give you some more information about which ones are different and how do they differ. But for now, we just know that there is some difference there. If we had another variable where there was no statistically significant difference, this is what it would look like. So we have a p-value that's 0.585, which is more than 0.05. So in this case, we would fail to reject the null hypothesis, as statisticians say, or we would accept the null hypothesis. And this is how you would report that, right? An analysis of variation showed that the mean score of the test, so that's the dependent or the outcome or the continuous variable for the 3 school settings. So here now we're talking about the different groups, or the categorical variable was significantly different, and we would actually report on the value of the F statistics here and the degree of freedom, as well as the p-value. And so there's another video that accompanies this that will show you how to run these tests in the SPSS platform.